In this video, we'll write the balanced net ionic equation for Sn plus HCl. This is tin plus hydrochloric acid. It's a single replacement reaction where the tin pushes the hydrogen out. We end up with tin 2 chloride and hydrogen's all by itself. So to do this, the first thing we have to do is balance the molecular equation. This is the molecular equation. I can see I have 2 chlorines here and just 1 here. So I'll put a 2 in front of the HCl. That balances the hydrogens, and the tin's already balanced, so we're done. This is the molecular equation. Now we can write the states for each substance. So tin, this is a metal. It's going to be a solid. Hydrochloric acid is a strong acid. You should memorize that. And it's going to dissolve, dissociate into its ions. So it'll be aqueous. Chloride's very soluble, aqueous. H2, when you see it like this is a gas. So we have our states. Now we can split the strong electrolytes into their ions for the complete ionic equation. So tin, we can't split that apart. It's a solid, so just Sn, and I'll write the states later. Hydrochloric acid, hydrogen, 1 plus, the chloride ion, 1 minus. So I have 2H plus 2Cl minus, so 2 chloride ions. And those are the reactants in our net ionic equation. For the products, tin is a transition metal, so we don't know the charge on this. We have to look at what it's bonded to. We said the chloride ion minus. So 2 times 1 minus, that's 2 minus, has to be 2 plus. So we'll have the tin 2 ion plus the chloride ion, and we have 2 of those. So we put a coefficient of 2, plus we have just hydrogen gas. We don't split gases apart in net ionic equations. This is the complete ionic equation. Now we can cross out spectator ions. They're on both sides of the complete ionic equation. We have tin here, then we have the tin 2 ion. These are different. Can't cross those out. 2H plus is different than H2. But 2Cl minus in the reactants and then in the products, that we can cross out. These are our spectator ions. What's left? That's the net ionic equation for Sn plus HCl. I'll clean this up, write the states. We'll have our net ionic equation. So this is the balanced net ionic equation for tin plus hydrochloric acid. We have 2 times 1 plus, that's 2 plus on the reactant side, and then on the product we have this 2 plus here. Charge is conserved, and if you count the atoms up, they're conserved as well. So the equation is balanced. This is Dr. B with the balanced net ionic equation for tin plus hydrochloric acid. Thanks for watching.